Bismillahirrahmanirrahim. Hello students, this is Hamza Noor from Aero Education Network. Welcome to another video. And in this video, I'm going to discuss a few more questions from differentiation, A-level maths P3, Cambridge 9709. And first of all, we have question number 18 of the handout, which is October-November 2013, paper 32, meaning paper 3, variant 2, question number 4. So let's see what the question says. The parametric equations of a curve are x is equals to e raised to the power of minus t times cos t and y is equals to e raised to the power of minus t multiplied by sine t. We need to show that dy over dx is equals to tan t minus pi over 4. So first thing first, what we know the fact is that x as a function of t is given to us as a product of two different terms. Okay, so what we are going to do, we are going to use the product rule of differentiation. So u is equals to e raised to the power of minus t. So u dash is equals to minus sine multiplied by e raised to the power of minus t. Okay, since you have studied the basic concept that when you differentiate e raised to the power of kx with respect to x, so first you write e raised to the power of kx as it is and then you multiply it with k. So I hope you have studied all of these basic concepts before attempting the past paper questions. Okay, so u is equals to e raised to the power of minus t. So u dash is equals to minus sign is multiplied by e raised to the power of minus t. Meaning first we write e raised to the power of minus t as it is and then multiply by the derivative of minus t with respect to t, which is minus 1. Okay, and then v is equals to cos t. Okay, so therefore v dash is equals to minus sine t. All right, because when we differentiate cos x, okay, with respect to x, so what we get is minus sine x. This standard form is given to you in the formula booklet as well. So v is equals to cos t. So therefore v dash is equals to minus sine t. So as we know that when y is equals to u times v, so dy over dx is equals to uv dash plus vu dash. Okay, you need to remember this sequence uv dash plus vu dash. This is the formula for differentiation using the product rule, which is given to you in the booklet as well. All right, so u times v dash, this is supposed to be e raised to the power of minus t multiplied by minus sine t. Okay, and then plus vu dash, this is supposed to be cos t multiplied by minus sine multiplied by e raised to the power of minus t. So this is basically the dx over dt function. Okay, we are actually differentiating x with respect to t. So this is just a concept which I have mentioned over here. Okay, so what's happening actually right now that we are differentiating x with respect to t. Okay, I'll just bring this working a little bit down so it should not look that it is being overlapped with that box. एक अटेम्प्ट में सेलेक्ट हो जाए तो क्या ही बात है, हो गया सेलेक्ट, अच्छा कॉपी हो गया, सेलेक्ट हो गया नीचे आके. ओके, all right, so dx over dt is equals to e raised to the power of minus t multiplied by minus sine t plus cos t multiplied by minus sine multiplied by e raised to the power of minus t. Okay, so what I can say is that in this dx over dt function, what I can say is that dx over dt function is equals to taking e raised to the power of minus t as common multiplied by minus sine t minus cos t. Okay, so far we have achieved this thing. And now we are going to differentiate the y function, meaning y as a function of t. Okay, so y is equals to e raised to the power of minus t multiplied by sine t. I'm going to do the working over here. Y is equals to e raised to the power of minus t multiplied by sine t. Okay, so u is equals to e raised to the power of minus t. Therefore, u dash is equals to minus sine multiplied by e raised to the power of minus t. And v is equals to sine t. So therefore, we are going to say that v dash is equals to cos t, because you know the concept that when you differentiate sine x with respect to x, you get cos x. This is also given to you in the formula booklet. So again, we are going to use the formula for product rule of differentiation. Okay, so dy over dt will be equals to uv dash plus vu dash. Okay, so u times v dash, this is supposed to be e raised to the power of minus t multiplied by cos t plus v times u dash, this is supposed to be sine t multiplied by minus sine multiplied by e raised to the power of minus t. So far we have achieved this thing. Okay, and now I can say that dy over dt is equals to taking e raised to the power of minus t as common multiplied by cos t minus sine t. Okay, so we have obtained the dx over dt function as well and the dy over dt function as well. So now we need to show the dy over dx function, and for that purpose we are going to use the chain rule formula. We need to show dy over dx exactly in this form, tan t minus pi over 4. Okay, so what I'm going to say is that, you know, dy over dx is equals to dy over dt is multiplied by dt over dx. Okay, so dy over dt, this is supposed to be e raised to the power of minus t multiplied by cos t minus sine t, and this is multiplied by dt over dx. Okay, so dx over dt will be reversed, उल्टा कर देंगे इसको. All right, so it is exactly the same thing as saying reciprocal of dx over dt function. Okay, to get dt over dx. So this will be multiplied by 1 upon e raised to the power of minus t is completely multiplied by minus sine t minus cos t. So far we have achieved this much. So now as we can see that e raised to the power of minus t and e raised to the power of minus t gets cancelled out. Okay, so I can say that dy over dx function is equals to cos t minus sine t divided by minus sine t minus cos t. So now what I can do is I can take minus sign as common in the numerator. Okay, one thing that when I take minus sign as common in the numerator, so this will be minus cos t plus sine t. But intentionally, I can express it like this, that in the numerator, when you take minus sign as common, so I will write it like this, sine t minus cos t over here. Okay, and upon taking minus sign as common multiplied by sine t plus cos t, because you know we need a specific form over here, so that's why I have expressed this fraction in this way now. So as you can see that this minus sign gets cancelled out, and therefore we are going to say that dy over dx function right now is sine t minus cos t divided by sine t plus cos t. Okay, so as you know already that we need to express dy over dx like this, tan t minus pi over 4. Okay, the angle in tan is t minus pi over 4. And for that purpose, we are going to make a comparison with the expansion. Okay, and what we have is dy over dx is equals to sine t minus cos t divided by sine t plus cos t. Now, how to convert it in the form of tan such that you get an equivalent expression for this dy over dx function? Okay, and for that purpose, I'm going to say that we need to perform a step that multiply the numerator and denominator, multiply the numerator and denominator by 1 upon cos t. Now the question arises in a mind that sir, how do we know that how to perform this step? सर हमें कैसे पता कि यहाँ पे ये स्टेप परफॉर्म करना पड़े? So what you need to understand is that you need to express dy over dx function in a particular form, in a specific form. Okay, and that is basically tan t minus pi over 4. So obviously you need to keep that expansion identity in your mind, which is given to you in the booklet as well, and you need to make a comparison. So our sole purpose right now is to express an equivalent form where in the numerator and the denominator of this dy over dx function, we need to introduce tan t over here. Okay, so what's going to happen is that when you multiply 1 upon cos t at the top and at the bottom, so the effect of 1 upon cos t will get eliminated. But if you don't eliminate it, so you would be getting an equivalent expression for the dy over dx function, which will be in the form of tan t. This makes sense to you or not? Okay. So if I give you a basic example, let's say 8 upon 2, which is 4. But if I multiply 8 with 2 and this 2 with 2, I mean, if I perform a step that multiply the numerator and denominator by 2 each, okay, so this will be 16 divided by 4, which is also 4. So 8 over 2 can also be expressed as 16 over 4. 8 over 2 will give you the outcome 4, and 16 over 4 will also give you the outcome of 4. However, both are equivalent to each other. They are giving you the same outcome, but the way of expressing them is not the same. So you need to understand this basic thing over here. Okay. So multiply the numerator and denominator by 1 upon cos t. I can also say that this step can also be expressed in simple English, that divide the numerator and denominator by cos t. These both statements are equivalent to each other. This makes sense to you or not? We can say that divide the numerator and denominator by cos t. All right. So what I'm going to do is multiply 1 upon cos t in the numerator and multiply by 1 upon cos t in the denominator. So the effect of this thing will be dy over dx is equals to sine t over cos t minus cos t over cos t, and this is divided by sine t over cos t plus cos t over cos t. All right. And here is basically another thing, that the proof of the formula of tan a plus b, if you understand the proof of this formula tan a plus b, although the proof is not required to you in the exam because this formula is given to you in the booklet, okay, but the proof is established in a same way by performing a same type of a step over here. Okay, by using the expansion of sine a plus b upon cos a plus b. Okay, when you expand sine a plus b divided by cos a plus b. At the top you expand sine, at the bottom you expand cos. Okay, so basically the same type of steps are being performed over here because we need a specific form in the form of tan t. That's basically the whole concept, the whole idea behind this. Okay, so what I am going to say is that what I'm going to do now, since in place of sine t over cos t, I can write tan t, and cos t divided by cos t, this is 1. So tan t minus 1 divided by tan t plus 1. Now what you need to understand over here is that, since the expansion of tan a plus b is tan a plus tan b divided by 1 minus tan a times tan b. And also, this thing when you expand tan a minus b, so minus sign is in the numerator and the positive sign is in the denominator. Okay, so you need to make a comparison with this form over here, and for that purpose I'm going to write this dy over dx function intentionally as tan t minus 1 divided by 1 plus tan t. All right. And now what you need to understand is that in place of this 1 in the numerator, in place of this 1 actually after the minus sign, or you can just say minus 1, what I can replace in terms of tan. You must be well aware that the value of tan pi over 4 is equals to 1, isn't it? Okay. So I'm going to replace tan pi over 4 with 1 in the numerator. So this will be tan t minus tan pi over 4 divided by, in place of this one, you cannot write tan pi over 4. Why? Because if you do a comparison, here you will write 1. This makes sense to you or not? However, what I can do is, since this term tan t is over here, so tan t is basically exactly the same thing as saying tan t multiplied by 1. And now in place of this one, I can write tan pi over 4. So I'm going to write it like this, 1 plus tan t times tan pi over 4. And now you can say that this is exactly the form of tan t minus pi over 4. Okay, and in this way you have shown your dy over dx function. As simple as that. Okay, you just need to make a comparison. You need to be well versed with all of these identities. Okay, all of the identities and formulas must be on your fingertips throughout the year. Even though they are given in the booklet to you, but it's still, all of the identities, okay, they must be on your fingertips. All right, because when you go in the exam, sometimes if you forget any identity, you can just see the booklet. But when you are practicing the questions throughout the year at home, all of the identities should be in your mind. Okay, so that is basically the whole scenario going on over here. Okay, I'll make you go through this whole working again. Okay, what we did, we achieved this form, dy over dx is equal to sine t minus cos t divided by sine t plus cos t. And then I performed this step, multiply the numerator and denominator by 1 upon cos t, which is exactly the same thing as saying divide the numerator and denominator by cos t. So as you know that I've written multiply by 1 upon cos t, and in the bottom multiply by 1 upon cos t. So the effect of 1 upon cos t will conceptually cancel out. But if you don't cancel it out and you just expand it, so you would be able to get an equivalent form for this sine t minus cos t divided by sine t plus cos t, which is over here. All right. And then we have successfully, obtained it in the form of tan t. All right. And then we have just made the comparison with the trigonometric expansion formula. Obviously, we are going to make a comparison over here, right? So what I want you to understand is that in place of this one, I replaced tan pi over 4, but in place of this one, I did not replace tan pi over 4. Why? Solely due to reason, because when you expand tan a plus minus b, so here you get 1. All right. And specifically, we are looking at the expansion of tan a minus b. So that's why in place of this one, I have not mentioned tan pi over 4. However, as we have seen that, this is tan a times tan b. So in place of tan t, I can write tan t multiplied by 1. So in place of 1, I can write tan pi over 4. So tan t multiplied by tan pi over 4. Okay, and now you can exactly say that this is the expansion which we are looking for tan t minus pi over 4. All right. Alternatively, what you can also do is that, you can start with the expansion of tan t minus pi over 4. You know, Alternatively, what you can also do is that when you start with the expansion of tan t minus pi over 4, so first you expand this. So this will give you tan t minus tan pi over 4 divided by 1 plus tan t times tan pi over 4. Okay. And in place of tan pi over 4, you are going to write 1. So tan t minus 1 divided by 1 plus tan t. Okay, and now what you can do is you can express this expanded form in the form of sine and cos. Okay, so in place of tan t, you are going to write sine t over cos t and then minus 1, and this is divided by 1 plus sine t over cos t. And then you are going to simplify the numerator and denominator, and then you can show that this is exactly equivalent to this expression which you obtained over here, sine t minus cos t divided by sine t plus cos t. So you can prove it in this way as well. All right, if it not clicks you with the first approach which I've mentioned, but the first approach which I've mentioned, you need to understand that very well. Okay, so if you just do the simplification, I'll bring it on the next page. Okay, so I'll take the LCM. So LCM in the numerator will be cos t. All right, and cos t into 1 is cos t, so sine t as it is, and then minus what, cos t. All right, and here the LCM is also cos t. Okay, and 1 times cos t, so this is cos t plus sine t. So therefore we can say that this cos t and cos t gets eliminated, and therefore you are left with sine t minus cos t divided by sine t plus cos t, which is exactly the dy over dx function which you obtained earlier. Okay, so through this alternative approach, we have established that, tan t minus pi over 4 is exactly equivalent to sine t minus cos t divided by sine t plus cos t, and this is basically the dy over dx function which we obtained earlier by differentiating the parametric equations. So therefore dy over dx is equals to tan t minus pi over 4. You can prove it in this way as well. All right, so I've explained this thing with both of the approaches. All right, so here we have discussed this particular question, which is question number 18 of the handout, October-November 2013, paper 32, question number 4. So now let's move on to the next question. All right, so now let's move on to the next question. This is question number 19 of the handout. Okay, which is May-June 2014, paper 32, question number 4. Okay, and this is basically the paper in which I myself appeared in P3 exam. Okay, 11 years ago. So 11 years ago, I did my A levels from the city school PAF chapter, and I got A star in A level mathematics. And so this was just a little bit thing to share. So this is May-June 2014, paper 32, question number 4. The parametric equations of a curve are x is equals to t minus tan t, okay, and y is equals to ln cos t. For t is greater than minus pi over 2, less than pi over 2, part 1 requirement is to show that dy over dx is equals to cot t. So first thing first, we have x as a function of t, okay. So x is equals to t minus tan t, and we are going to differentiate x with respect to t. So dx over dt is equals to, when t is differentiated, this is 1, and then minus sign, and then when we differentiate tan t, we get sec square t. So dx over dt is 1 minus sec square t. As you know, the fact that when you differentiate tan x with respect to x, what you get is sec square x. All right. This form is also given to you in the booklet. All right. So dx over dt is equals to 1 minus sec square t. And then we have y as a function of t. So y is equals to ln cos t. Okay, and as you know the fact that when we differentiate ln fx with respect to x, what we get is 1 upon fx multiplied by f dash x, meaning this whole fraction 1 upon fx is multiplied by f dash x. Alright, so when we differentiate ln fx, we get f dash x divided by fx, which is exactly the same thing. Alright, so this is basically established by the chain rule and the differentiation of ln functions. Alright, so when we differentiate y with respect to t, so dy over dt is equals to 1 upon cos t, and this whole fraction 1 upon cos t is multiplied by minus sine t, because when we differentiate cos t, we get minus sine t. So far we have achieved this much, and now I can also say that dy over dt is equals to minus tan t. Okay, because minus sine t over cos t is exactly the same thing as saying minus tan t. And now we are going to obtain the dy over dx function using the chain rule. Okay, so dy over dx is equals to dy over dt multiplied by dt over dx. Okay, so dy over dt is minus tan t, and this is multiplied by dt over dx. So dx over dt will be reversed, meaning multiplied by 1 upon 1 minus sec square t. Okay, so therefore we can say that dy over dx is equals to minus tan t divided by 1 minus sec square t. So far we have achieved this thing. Now, as you know that we need a specific form, we need to show that, we need to prove this, that dy over dx is equals to cot t. Okay, and now we are going to use some identities over here. Now, as you know the fact that, a basic identity in P3 which we have studied is 1 plus tan square theta is identical to sec square theta. So I can say that 1 plus tan square t is equivalent to sec square t. All right. And in place of sec square t, I can write 1 plus tan square t. So this is going to be dy over dx is equals to minus tan t divided by 1 minus, in place of sec square t, I'm going to write 1 plus tan square t. So dy over dx is equals to minus tan t divided by 1 minus 1 minus tan square t. Okay, so 1 minus 1 gets cancelled out. All right, and therefore you are left with minus tan t divided by minus tan square t. This minus sign and minus sign also gets cancelled out, and you are left with 1 upon tan t only, and 1 upon tan t is basically identical to cot t. Therefore, we have shown that dy over dx is equals to cot t. This is supposed to be your answer to part 1. All right. So now let's move on to the next part. So now moving on to part 2, which is just for 2 marks. Okay. What we need to find the x coordinate of the point on the curve at which the gradient is equal to 2. Okay, and we need to give our answer correct to 3SF. So the gradient is equals to 2 means that dy over dx will be equals to 2. Meaning the dy over dx which we have shown in part 1, which is cot t. So cot t will be equals to 2, and we need to solve this trigonometric equation in the interval that t is greater than minus pi over 2 less than pi over 2. Okay, this is basically the interval which you are given over here. And as you know that we need x coordinate of the point on the curve. So obviously x as a function of t is given to us. So first of all, we need to find the value of t at which the gradient is equal to 2. This makes sense to you or not? Step by step chalenge na? So cot t, in place of cot t, I'm going to write 1 upon tan t. So 1 upon tan t is equals to 2, which means tan t is equals to half. All right, and then we are going to solve the trigonometric equation in the usual way, which we do so far since P1. Okay, so first of all, I'm going to find the basic angle alpha. So basic angle alpha is equals to tan inverse half. Okay, so what is the value of tan inverse half? Your calculator must be in radian mode. Okay, so tan inverse half is supposed to be 0.4636. Okay, I'm going to pick this alpha correct to 4SF. All right, 0.4636. All right, this is the basic angle alpha. And as we know that we are dealing with a positive value of tan, and tan is positive in the first quadrant and the third quadrant. And since the interval is minus pi over 2 till pi over 2, okay, so minus pi over 2 till pi over 2, we are going to only deal with the first quadrant. All right, so this is basically angle alpha. Basic angle alpha is always between the slant line and the horizontal axis because basic angle alpha is acute. Okay, you must be well versed with all of the concepts of trigonometry. Okay, before starting differentiation in P3, your P3 trigonometry should be completed. Okay, so your concepts of P3 trigonometry and P1 trigonometry should be very good. All right, before starting differentiation. So basically, it's a prerequisite that your P3 trigonometry should be completed before starting differentiation topic. Okay, so here I'm just going to say that T is equals to 0.4636. All right, we need our final answer x coordinate correct to 3SF, but it's recommended that in the procedure of your complete working, you pick higher degrees of accuracy in your values in order to avoid premature approximations. Okay, so t is equals to 0.4636 I have picked over here, and since x as a function of t is t minus 10t, okay, and in place of 10t I can write half. Okay, so this is going to give me more accurate value, right? So x is equals to 0.4636 minus half. Since in place of t I can write 0.4636, in place of 10t I can write just half. As simple as that. No worries with that. Okay, so x is equals to 0.4636 minus half. This is supposed to be minus 0.0364. X is equals to minus 0.0364 correct to three significant figures. This is correct to 3SF value. Okay, when you have a zero before the point and zero after the point, so this zero is insignificant. Okay, you need to know these all basic concepts which you are studying since O level maths. So therefore, x is equals to minus 0.0364 is your answer correct to three significant figures. Okay, so this was the complete solution of this question. So for the sake of this video, I have discussed two questions. This one is May June 2014 paper 32 question 4, and the earlier one was कौन सा हो रहा था? It was October November 2013 paper 32 question number 4. All right, so I'll be uploading more recordings inshallah. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.